So we're going to start looking at calculus in terms of changes and rates of change. So we're going to just start by looking at changes in functions, and then we're going to try to relate that to rates of change in functions, or slope. Okay, so rates of change really means slope. So we need to figure out the change. We're looking at changes first, so changes in y. So some of you may have noticed this pattern in parabolas, but if we take a look at the changes in the y values in parabolas, okay, so if I go from, so I've given you a table of values here for y equals x squared, and if you take a look at the changes in the y values, we've gone from 9 to 4. Okay, so we've got from 9 to 4, that's going to be a plus or minus 4 change. Okay, or sorry, minus 5 change. Okay, and if we go from 4 to 1, we get a minus 3 change. And if we go from 0 to 1, sorry, 1 to 0, we get minus 1. And then we go from 0 to 1, it becomes plus 1. And if we go from 1 to 4, we go plus 3. So if you take a look at this pattern of change in the parabola, look at the changes. It is what we call a linear change. Okay, it's just going down by a constant amount. So it goes minus 3, or it's going up by, it's going plus 2, plus 2, plus 2, plus 2. So I'm going to write it in, but I want you to recognize this change. This is a linear change. Okay, so plus 2, plus 2, plus 2, plus 2. So in this particular parabola, some of you may have recognized this before. Okay, when we looked at the perfect squares, there was a change of plus, 1 to 4 was plus 3, 4 to 9 was plus 5, 9 to 16 was plus 7. This change in the y values of a parabola, or in this case y equals x squared, happens to be a linear change. Okay, the changes are linear. So let's take a look at these other ones and see if this pattern exists in general. Okay, so this one is 2x squared plus 1. So I've given you a table of values, and we're going to look at again the changes in y. So from 9 to 3, we have a minus 6 change. From 3 to 1, we have a minus 2 change. From 1 to 3, we have a plus 2 change. Plus 2. Okay, from 3 to 9, we have a plus 6 change. From 9 to 19, we have a plus 10. And again, notice that the changes in the y of the parabola are going to be a linear change. So this follows a linear pattern. We get plus 4, plus 4, plus 4, plus 4. Okay, so this is a linear change. So then we can look at one more parabola here. And I've given you a table of values here for 1/2 x squared plus 5. And going from 7 to 5.5, we get a minus 1.5 change. Okay, from 5.5 to 5, we get a minus 0.5 change. And then we're going to go up 0.5. Okay, we're going to go up 1.5. And we're going to go up plus 2.5. And from 9.5 to 13, we go plus 3.5. Again, you can see that the changes in y are linear changes. We're going up 1, up 1, up 1, plus 1, plus 1, plus 1. So what we can say about the first change of the quadratic, and we're going to look at second changes as well. So we're just going to talk about the first change. The first changes in quadratics, the first layer of changes, is a linear pattern. So they are linear. Okay? And that's important. We're going from quadratic, and maybe I'll write it out this way. We have a quadratic, okay, and the changes are linear. Okay? And we can actually generalize that. We can say that the changes in the y value follow a linear pattern for quadratic. So let's take a look at cubic functions. How do cubic functions change? Okay, well, we're going to look at the first and second changes. And we're going to maybe establish what the first change is when we take a look at the second change. So we've got the first change here and the second change here, which I've indicated by the delta squared. Okay, it's not actually a squared, but it means the second change. So here's a cubic function. I've given you the cubic function 1/3 x cubed. And here's the x and y values. And when I look at the first changes of the y values, from -9 to -8/3, okay, so that's -27/3 to -8/3, we've gone plus, that's going to be plus 19/3. Okay, I've done my math right. And from -8/3 to -1/3, I've gone plus 7/3. Okay. And then from 1/3 to 0, I've gone plus 1/3. Okay, here I've gone plus 1/3. I've gone plus 7/3. Okay, and then to 9 is going to be plus 19/3. So it's kind of symmetrical, which is interesting because this is a cubic function and our changes are symmetrical. And we'll see why they're symmetrical once we look at the second change. Okay, so taking a look at the second change, from 19/3 to 7/3, we went -4. Okay, here we went -6/3, so -2. Here we went plus, did I do that right? Yeah, minus. Okay, here we've gone plus 1/3 to plus 1/3. There's no change, so that's 0. Plus 1/3 to plus 7/3 is plus 2. Okay, and then we get 12/3, which is plus 4. So looking at the second change, you should recognize this as a linear change, plus 2, plus 2, plus 2. This is a linear change. So second change being linear, which indicates that this is quadratic. Okay, and which makes sense because this is symmetrical, and it looks like it's symmetrical just like a quadratic would be. And in fact, it is a quadratic function here. So the first change of a cubic function is quadratic, and the second changes are linear. So what's the pattern of the second changes? They are linear. Okay, we have linear change. We have linear change. So the original change, okay, so this change here must be quadratic. Okay, the original y, sorry, in this case here, this is the first change then, which I'll write like this. The first changes are quadratic. Okay, so this is what we're going to make as a generalization then. We're going to say that a cubic function its changes are quadratic. Okay, and the change for quadratics then, we go from quadratic to, oh, this is quartic, sorry. So if the first change is quadratic of cubics, and the first change of quadratic is linear, there is a pattern that's establishing here. And what we can say then is, and we'll write it like this. This is a third degree. Its changes are second degree. And we also saw that the second degree changes, that means change, that little delta there, are linear. So if we kind of go backwards with this reasoning, a quartic function, we can say that a quartic function, its changes are cubic. Okay, and so we say the fourth degree, its changes our third degree. And then we can make this inference, although we have no proof of this. The pattern does tend to lead us towards that direction. We know that a power 5 change probably, and again we have no proof of this, is probably going to be a power 4. A power 4 change is probably going to be power 3. A power 3 change is probably going to be a power 2. And we've shown that power 1, power 2 changes are linear, okay, or just x.